Assalamu alaikum and welcome back to the fifth program on Java, prime number check. So go ahead and create a check prime class and create an empty constructor and create a public boolean is prime and then assign this. Okay, just create this and we're going to go ahead. First of all, we need to understand what is the prime number before proceeding to writing code. So a prime number is a one number greater than 1 that cannot be exactly divided by any one number other than itself and 1. So any number that could be divided by itself and 1, that is a prime number. Otherwise, it's not a prime number. For instance, 3, if we divide it in 2, it's going to give us 1.5, which is not that means that 3 is not a prime number. Okay? So what we need to do now, just jump into our code and start doing this. So first we need to check this int number, which is prime or not, okay? Now we're going to return just to do create a boolean. So boolean is prime, set it to true, okay? So before doing that, we need to check from a point to another point. For instance, if we entered 5, we need to go ahead and divide this number on every single number before that. So we're going to divide 5 on 1, 2, 3, 4, 5 and up to 5. Or just we know that 1 and 5, any number could divide it on 1, so no need. And also any number could divide it on itself, so no need. So we get this number. So we kind of having from 2, the starting point from 2, up to n minus 1. For instance, if 5, it is n. So we kind of having this from n minus 1. So from 2 up to n minus 1, which is the number, could be 5, like this. So basically, this is if we have some great numbers, really big number, like 10,000 or something like this. Checking all of these numbers is really, really bad. Could take time and so on. So what we need to do, just to check the before up to square root of 5. Up to square root of 5, like this. So to understand this, reading this document is going to help you. So I'm going just to explain this, and you're going to find it also in my description on the GitHub repository at the docs folder. So if a number is is not prime, it can be written as a product of two numbers. So any number could be written, of course, of two numbers. So like 5, it's equal to 1 multiplied by itself. 5 by 1 is multiplied by 1 is going to give us the n that we're looking for, which is 5. So n is equal a multiplied by b. That means that n we could divide around a or divide around b. Okay. So at least one of a or b must be smaller than the square root of n, because we cannot multiply the same number by itself. So for instance, if we multiply 5 by 2, it's going to give us 10, and 10 is greater than 5, so it's not correct. Okay, so any number should be, one of them should be smaller than the square root of the provided number. So to understand that well, you could just check this example here, which n equal to 16. So the factors of 16 are 1, 16, 2, 8, because 2 multiplied by 8 is give us 16, and 4 by 4 is give us also 16. So the square root of 16 is 4. So as you notice here, that the max number could be 4. We cannot both of them be greater than the 4. If we just took one of them greater than the 4, like 4 and 5, we're going to get 20. Okay, so this is if you want to look at this document to grasp and understand more. Okay, so what we need to do now is just to go starting our for loop for int, as I said, from I up to number divider on 2. This is also correct. We could use division on 2 or use this the square root. So let us give us a shot now. Okay, so now what we need to do is just to check, is the modular of that number, like if we catching that number divided in 2, is this going to equal 0? If it is going to equal 0, it is not prime. We're going to set it to false. Okay, and if it's else, we're going just to return just the set is prime to true, which is true. Okay, so that's it. So all we need to do here to return is prime, like this. I hope it's clear. We're going to test this in both with square roots and also by division. So what we need to do now, I'm going to close that factorial and go here, remove, let me go to check prime and update this to check prime. And let me go with is prime, and here what we have is prime, like this function, and it's accepting input, which is also a number. So let me run this and see. Okay, let me enter number 5. So the expected output is true, not returning any. Because here is prime, we should return is prime. Okay, and of course here it's not going to print anything. I just remembered, because we here we did not get anything, so this is returns a value. So let me check if is prime, print the number, input number is a prime, otherwise else it's not prime, like this. So let me just go ahead and do this. No need for returning that value there. I run it with debugging. So let me run it again with no debugging, because no need for that. Okay, let me go with 5 again. As you see here, the number 5 is a prime number. Let me go with 4. Check 4. 4 is not a prime number. So this is the first way, and we could just comment it. Okay, I'm going to comment it to leave it to you, and scroll here. And what we're going to do, instead of division, we're going to use the square root of the number. So math that square root of a number. Again, let us go to the app and run. And again, 5 is a prime number and 4 is not a prime number, as you see here. So this is the program. All the docs, you're going to find it on my GitHub repository. So now we're going to move on to the next program.